Greetings everyone, let us now tackle the summation of infinite geometric series. Now before doing some examples, it is important to know some different cases of Sn depending on the value of our r. Okay, so let's start. So what if our value of r is greater than 1 or r is lesser than -1? Now if we take a look at our formula, if r is greater than 1 or r is lesser than 1, this summation right here will get larger and larger as n approaches infinity. It will increase, it will become larger and larger. So we can say that we have no definite sum, no finite sum for this values of r, okay, within these ranges. Now another case is when r is equal to 1. Now for r is equal to 1, if we take a look at our formula, we cannot use this formula because in the denominator, if r is 1, then it will be undefined. Now let's just use the definition. Let's say we have a1 is equal to 2 and our r is equal to 1. Okay, what happens here? What is our geometric series? So we have 2 plus 2 plus 2 plus and so on. It will continue up to infinity, and the same thing happens. We cannot arrive at a finite sum. Okay, now we have here another case. What if r is equal to -1? Okay, let us use the same numbers here. a1 is equal to 2 and r is equal to -1 in this case. So if that is the case, we will get 2 minus 2 plus 2 minus 2 plus 2 minus 2 and so on. So it will continue to infinity. Okay, as our number of terms is infinity here. So we can say, if we take a look closely at this series, that the summation, our Sn, will alternate from 0 or 2, right? So if these are the only terms, then summation is 0, and we have this one, the summation is 2 and 0 again, and 2 and 0 and 2 again. So it will vary from 0 to 2, and we can say here that again we have no definite or finite sum here. Now the last case right here is if r is lesser than 1 and if r is greater than -1. In other words, the value of r is in between -1 and 1. Okay, so an example would be a1 is equal to, let's say a1 is equal to let's just use 2 again. So a1 is equal to 2 and our r is equal to 1/2. Okay, now let's substitute these values to our equation. Okay, so we have a1, that is 2, multiplied by 1 minus 1/2 raised to n, right? All over 1 minus 1/2. Okay, so as n approaches infinity, 1/2 raised to n right here will approach 0, right? This value will become smaller and smaller, and it approaches 0 as n approaches infinity. So we can rewrite the formula actually. So Sn is equal to a1, and this will approach 0, so we can write this as 1 over 1 minus r instead of 1 minus rn in the numerator. Okay, so in this case we actually have a finite sum. So we have a finite sum for this particular case. Now the examples in the next video will focus on this case and exploring the different scenarios of r within this range. Okay, now there is actually another case within this particular range. So what if r is equal to 0? Now let's say we have an example, a1 is equal to 1 and r is equal to 0. Now if this is the case, our series will look like this: 1 plus 0 plus 0 plus 0 and so on. So our summation is actually the first term 0. Okay? So, but in the examples in the next video, we will focus on values within this range other than 0. Okay? So, thank you for watching this video. I hope you learned something and I will see you in the next video.